Hello, it's Carly McAvoy. I want to show you some different graphs. One of the things you'll be asked to do is to take an equation, plug in some values into that equation, get ordered pairs, and then graph the equation. So the first one is a linear equation. Notice that the x is to the first power. And you can remember that linear equations are called linear because they make a line when you graph them. So you should have the skills to plug in and simplify and find the ordered pair. So I'm not going to go through that as much. I just want to show you the different types of graphs. So if x is 0, then we put 0 into our equation and we simplify to get -2. And so we know the ordered pair is 0, -2. If x is -1, you replace the x with -1 and simplify to -4. And finally, if x is 3, you would get 2 times 3 is 6 minus 2 is 3, 4. So you could look over here and plot those, but mostly I just want you to remember first power is a line. This right here, the number in the front, determines our slope or shows our slope. And since that slope is positive, we see a line that's rising from left to right. This number at the end is our y-intercept, which is -2, and that means we cross the y-axis at -2. Okay, let's go on to the second one. The second one is not a line. Whoops, it's showing as a line. Let's put this in differently. Instead of a line, what we have here is x squared minus 1. So let's do that. We're going to edit our function. This is a great program to use if you'd like to be able to graph and see the graph of things. It's free. It's called Graph, and you can go easily online and download that graph program for free. Okay, so x squared minus 1 does not look like a line. It looks like a parabola, and that's also something you may have seen before. Notice that the -1 at the end, again, is where we cross the y-axis, which is at -1. If I plug values into this, if x is 0, 0 squared is still 0, minus 1 gives us that -1. If x is -1, then -1 squared is 1, minus 1 should be 0, right? I don't know what I have going on here. But what happens for the second one? Well, if it's 1, 1 squared is also 1, and 1 minus 1 is also 0. So if you plug in a negative or a positive 1, you get the same answer. Look at our graph. If x is 1, y is 0. If x is -1, y is 0. If x is 2, y is 3. If x is -2, y is 3. So negative and positives, when we plug them in, turn out to give us the same y value. But that's how parabolas work because it's second power. So a second power equation looks like a parabola. Because this number in the front is positive, our parabola is opening up. If we were to change that to negative, it would open down. I could just go in and change that one thing, and that is put a negative in front of this. If I put a negative in front of that original equation, then all of a sudden it opens down. So I can tell just by looking at the sign of that lead term whether it's going to open up or down. If it's positive, it opens up. If it's negative, it opens down. All right, let's take a look at the third one. The third one is to the third power. This is called a cubic equation. Look at the shape of this. Very interesting. However, we're down here at -8 is where it crosses the y-axis, and that is what we have here at the end. So we start to see some patterns in these. When we plug in values for the cubic, let's see if I did this correctly. If x is 0, that goes away and we get -8. If x is -1, -1 to the third power is -1. Minus 8 is -9. Would I get the same for 1? No. If I plug 1 in, 1 to the third power is 1, minus 7, minus 1, I don't know what the heck, minus 8. I did some copying and pasting here, give me a break. So 1 to the third power is 1, minus 8 is -7. All right, so we can see that if I'm at 1, then I'm down here at -7. Okay, so the thing I want you to realize, though, is you see how this equation from left to right is rising? That's because of this positive lead term. If I had a negative lead term, you would see that falling from left to right. I can do the same thing, go in and put that negative in and let you see what that would look like as a negative. That's a really nice thing about this program. Really quick, we can see what small changes would make to our graph. You see how now it's falling from left to right? It's still crossing at -8, but now it's falling because there was a negative in front. Let me put that back to positive. On your, what I'm going to be asking you to do is just to be finding the graph, choosing the graph. You don't have to actually plot the points yourself, but you should know that a third power equation is going to look like this. Okay, another type of equation is an absolute value equation. That is the absolute value of y, of x, minus 9. If x is 0, the absolute value is 0, so we get -9. If the absolute value of -1 is 1, 1 minus 9 is -8. But what about if we plug in -1 or 1? Is it the same? It is on this one because the absolute value of -1 and 1 is 1. So we get the same value and we get this repeating look, which is similar to what happened up here, even though we don't have a V shape, we have a U shape. But it repeats because no matter whether it's positive or negative, we get the same answer there. So an absolute value equation always has this V shape. Notice the -9 at the end and notice where it's crossing the y-axis. So that's nice to know that. Again, because this is a positive in front here, we're opening up. Okay, the last kind is a rational equation. It looks really different. Why do we have these two separate parts? Well, we have these two separate parts because we have an undefined expression at 0. If I was to plug x0 in for x, I'd have 2 over 0, and we can't divide by 0. So that makes that undefined, and that gives us this place where we can never have x be 0, so it doesn't touch either place. And then we can start to plug in. If I have -1, I get 2. If I have +1, I get -2. Now, if you were going to graph this by hand, you would want to find more points. I'm just showing you kind of how to plug, what they're asking you to do to plug in. They're going to ask you to plug in more points. But then they show you the graph, and you just have to choose it. So those are the types of graphs that I want you to be aware of in this first exercise. All right, have a great day.